With that, we're going to go ahead and kick it off for service workers. So again, my name is Jesse Sanders. I'm the CEO of Rebug, and we develop web applications for enterprise clients. So we're going to talk about web service workers tonight, and I got to put focus there. There we go. Talk about what it is and what it's not, and how you might be able to use this. So service workers, they're a progressive upgrade for modern web apps. So that's great. Well, what does that actually mean? Well, we're talking about background web workers. We'll go ahead and bring that back. They're background web workers. So they're actually running in the background. You don't even know about them. They're out in their own context, and they communicate via messaging. So you're not able to just directly plug right into them, but you can communicate with them via messaging, and we can start to do some pretty cool stuff with them. They're also privacy. So what they are is they're a safe man in the middle. So usually when I hear man in the middle, I'm like, uh-oh, if you have a problem. Well, think about if you have this proxy that's actually running there and all of my calls are going through it, and there I can start to intercept calls and maybe react a little bit differently than just having it go straight out to the server. And we'll dig into that a little bit more. But basically it acts as a proxy. If there's no network connection, it can go ahead and take over. We can go ahead and add some features and say, hey, let's go ahead and use some caching here. So I've got no network connection, but let's say I've written a progressive web app and I pull it up on my phone and all of a sudden it shows a little dinosaur image and that's horrible. I need it to show something so I can actually have that cached so that the user can go ahead and see that base version of the app, and then I can go from there. I could actually bring in other cached data. I could start to do a couple of different things. I can also start to do things like background sync, and we'll talk about the importance of that a little bit later. Offline first. It's kind of a different way of thinking about, we've all been developing web applications, and offline first is definitely not the way we've been thinking. It's been about like, hey, how big of a pipe can I get? How much throughput can we do? What kind of cool stuff can we do? So really, there's a group called Offline First Org, and it's really a philosophy similar to mobile first, okay? And really the idea is that treat networks as a nice-to-have upgrade. So that's a really big paradigm shift in how we've been developing apps, where it's always been, well, guess what? No network, no app, and you'll have to wait till you get an internet connection. That works great for people sitting in an office, but if I have people out in the field and they're working on devices out in the field, and all of a sudden, they're collecting a bunch of data, and all of a sudden they take 2 steps this way and they lost all their internet connection. Now I say when they click save, big network error. That's not really helping them get their job done. So what if we could actually have them go ahead and click save, and we go ahead and save it. And we save it locally. So build for offline first, right next to mobile first. So I think if we come from this concept, we start looking at applications this way, that we can really develop some really amazing applications that are going to work wherever we're at. Yeah, go ahead.
What's the tools that change this to offline first? If you don't offline first, caching data, it's almost like a desktop. So I'm wondering what are the tools that progress into this point?
Sure, and we're going to cover some of those tools that actually make this possible. So, because right now what we're going to do is we're just talking a little bit of the what makes up a service worker and why what's kind of the architecture to it. And we're definitely going to dig into those tools, and we're going to actually show you some live code samples. So hopefully nothing blows up while we're doing this. So I have a backup plan just in case. A really big point about this, we started talking about man in the middle. And that's where a lot of people, it just sets off, that's got a certain connotation to it. So the thing you really need to know is this is secure. The only way it's going to work is over HTTPS connections. Okay, so there's no way to have a man-in-the-middle attack. We have our little man-in-the-middle that's going to intercept our own network connections, our own network calls, and then we can, upgrade or degrade them based on our connectivity. But there's no way for someone to come in and hack this. They can be developed at local hosts. So I have to have a way of test this. I have to have a way that I can figure out what's actually going on, and HTTPS is not the answer. So the other opening they do have is I can test this during local host and running it locally during dev. So ultra secure. Context. So I can have service workers at different levels of my application. So I can actually specify a context, or I can allow it to just use the natural context based on the folder structure of where that service worker is placed. So with that, the path specifies the default context, and then it can be overridden during the registration process. So if I want to have this one, even though it's buried down in here, I want it to actually work across to everything, I can do that. I can also take one that's more at a top level folder and say, I only want to apply it to these areas over here. Okay, I could take and have a service worker file in each one of the different folders, folder structure levels, and have it do caching or syncing in different ways just based on the context of where it's located at in the file structure. So what can they do now? Caching's a really big one here. So I can cache static content. I can cache stuff like HTML, CSS, JavaScript. In fact, when we get to our demo here, you'll see we'll turn off all the network stuff, and man, it just loads right back up. All of it cached locally. Now I have to have it load once. I have to have the service worker be installed and run once, and then all that data will be cached for us. I can do preloading. So let's say I've got some really long running processes that take a long time for it to return. I can go ahead and do a bunch of preloading. With that, and preloading again can be HTML, CSS, JavaScript. I believe we can do data with that as well. We can do web push notifications. So think about it, I can be on a device, and even though it's not a native device, I can actually do push notifications down to that device and send them an alert, just as if it was a native app. And regardless whether it's on a phone, tablet, or desktop or laptop. So you've got some great stuff there. So you get kind of that native-esque push notifications for all your devices, whatever you're using. And the other big one we talked about is background sync. So I can save on a device now, and I can sync it later when I have an internet connection again. I never have to give a user an error. Sorry, man, no internet. You're done. Okay. So what can we do it with in the future? What's the roadmap for this? Where do they want this to go? Well, they've actually got some pretty big plans. They want to take the basic background sync and start to make it a periodic sync and open that up so that we can do syncing based on a certain time schedule and be able to do some of these actions, not only just, hey, as soon as I get an internet connection and flooding that, also, I can do some periodic stuff, different ways that we can take advantage of that. I can also do LBS and geofencing. LBS is location-based services. So what I can start to do here is if I give John here a device and he's supposed to be handing out flyers, and putting them on each person's porch, and all of a sudden we see that actually he's at the Arby's, 10 blocks away. It's like you're outside the geofence. You're not doing what you're supposed to be doing. So we can do some really cool stuff like that, and that's coming down the pipe here. So, who supports it right now? So right now it's growing. Chrome supports it, Firefox, Opera, and Edge. So sorry, IE8's not going to do this, IE9's not going to do this, Edge on up will do it. And if you notice, Safari's not in there yet. So, but Safari support is coming. Also, you can go out, there's a website here called Is Service Worker Ready? And I can go ahead and click on this. And I can start to see, okay, well, what is supported, what's not supported, promises, debugging. I can really get into what's being supported by each browser. This way I can determine, what I can actually do with this. And we'll start to look at about how I do this in an actual code, so I make sure that I don't expect caching when all of a sudden it's really not going to cache, and then we can degrade appropriately there. All right. So now we're going to get into a little bit of some code here. We're going to talk about service worker lifecycle. That includes installation, activation, the idle message loop, fetch and message, as well as terminate. So installation, it simply is the hook for preloading content, initializing the worker, any sort of stuff that we want to have happen as soon as it's initialized. And then let's see here, the activation, this is kind of interesting. It's a little bit different than what I would think initially when I heard this. Activation is actually after installation or after termination restart. And so since it is after termination restart, I might need to purge cache. I might need to go do some cleanup because it terminated and it maybe left it in a bad state. Now, I'm not always maybe going to have control of how the service worker terminated. So what I can control is what happens when it comes back up. This is my opportunity with this hook here to be able to clean anything up. We've got the idle message loop. And by the way, we'll look at some code examples of this. We're just kind of covering the high level here for you. So the idle message loop, really have two parts here, or actually three parts. We've got the fetch. This is the most common. So this is used for all network requests in the current context. So what do you mean by that? Well, let's say I want to load a list of customers. That's a fetch, okay? And the fetch is actually going to intercept that call, take a look and see if anything applies to it. Otherwise, we're going to pass that request along as it would normally go. If we don't write anything for it, it'll just go on and work the way that it always has. Message. Message is used to handle messages posted to the service worker. So if we need to send a message down to the service worker and we want to do something slightly different, I think we could probably send config changes or other sorts of things like that. That's how we could do that. And in terminate, this is part of the service worker life cycle. It actually, there's no hook for it. There's not much that we can do for it. I think we can just observe that it happened, and that's about it. All right, so let's talk about, this is kind of this all outlined here. So there's no service worker we go to a phase of we're installing the service worker. One of two things is going to happen. Either it's going to error out or it's going to activate. Hey, I'm up. I'm good. I'm running. Things are fantastic. I'm going to do any cleanup, any sort of cache dumping that I might need to do, and then we're good to go. And then I'm going to sit idle, and I'm going to wait, and I'm going to listen. So as a service worker, I'm going to sit there and wait, and I'm going to either listen for a terminated, and then poof, I'm gone, or I'm going to be listening for a fetch or a message. Okay, and that's just gonna sitting there in an idle loop, just waiting for something to happen. So let's talk about creating a service worker. There's really several parts here to it. We want to reliably register it. We want to make sure that we're able to register it and it does it systematically, and that especially like in a debug mode, we're getting some sort of at least feedback. Yep, it's registered. Yep, we're okay. Or hey, there was a problem, and then we can go investigate what that is. So then when we're creating a service worker, we want to figure out what things do we want to do during the install, what things do we want to have happen during the activate. Things like handling network requests, cache data, stuff like that. So one, as we're registering this, we want to check to see if the service worker and other dependencies are available. If it's not, let's say one of the first checks we're going to see here is, does service worker even exist? And if it doesn't, we're out. We're not going to attempt to register anything. Then we're going to check to see, hey, is cache available? If cache isn't available, then we're not going to be coding, anything for cache. The code will be there. We're just not going to execute any of it. We might check to see, like, if we want to do push notifications, we'll go check for that and see, hey, do we push notifications available? Let's see here. Oh, the other one is the idempotent. The main thing on this is that we want to make sure it produces the same result each time it's called during this registration. So we don't want to have it react differently or do stuff, outside of the out of the norm. Should respond the same way every single time, based on the preconditions. All right, so let's talk about registration. We want to guard with the service worker in Navigator. Like I said here, it's idempotent. Am I saying that right? Idempotent. Okay. And here's some actual code for it. So what we're doing here, if you look on this first line, we're checking, is service worker in Navigator? If that doesn't exist, then service worker is not supported by this. I would expect this to fail in Safari right now. Okay. My other browsers, yep, this is going to pass. And at that point, what I'm doing, I'm going to go ahead and do a window add event listener, and I'm going to do unload. Okay, I need to make sure that the window is loaded. We can't go off and fire a bunch of stuff off when we're still in this half-baked state. So once that callback is called, then I'm going to go ahead and get an instance of the Navigator service worker. And then from there, I can call register. So in this case here, I'm going to register a service worker called my service worker. It's in my root. It actually register has two parameters. One is for where the location of the script is, and the second one is for any sort of options that I might want to override. Most common one is I want to override the context of this. I only want it to work in this scenario, at this path, something of that nature. So then once that promise, so remember we said these are promisey, right? So once that promise resolves, then I want to go ahead and the real common thing here is let's go ahead and just do a console log, registration successful, and then pass out the registration scope. Otherwise, I want to go ahead and log out that the registration failed and then log that error so I can have a chance to debug it and maybe figure out what I did wrong. All right, so then installation. This resides within the service worker script. So we actually, if we go back here where we put where we loaded our script here on the fourth line for register, so any sort of installation stuff we're going to put in my service worker JS. And that's what's actually going to do the work. It's the first opportunity to cache data. We can preload data into the cache here. And it's actually pretty simple here. So we're going to go ahead and get a self actually points to the service worker, and then we're going to go ahead and add an event listener for install. And when that is called, our callback function here, we can go ahead and add our installation steps right there. So let's say we want to go ahead and cache some pages, or we want to go ahead and cache some data. We might make a call here, cache it, and then set that stuff aside so it'll be available later.
Well, we will be showing that.
And we're actually going to dig in to this and what this code looks like. So again, this is just kind of high level for what the hooks look like. So activation. So this runs after old workers have been stopped. So they might be terminated. It also runs right after the install as well. So this also resides within the service worker script. And it's an opportunity to remove old unused caches and data, any sort of stuff like that.
Just one more point.
Yep.
Two more
Go ahead.
One more point is whenever you update your service worker script, the activation is going to reoccur. You're going to download the new one, and you're going to reactivate.
It's a really good point. So what John is talking about is that anytime I go ahead and I'm making changes, I'm debugging, that's a good one, debugging locally. There we go. I think that is debugging, isn't it? Debugging locally. So anytime I'm doing that and I make a change to that, it's going to go ahead and notice that file has changed, and we're going to reload the service worker. And in that case, then it's going to reactivate it. It's already installed. And that's one of the things that I'll show you here is when we get into the demo, is even though I close out the browser, everything's great, and I come back in, guess what? It's still there. My service worker is still there. So
how do you avoid dead reads?
How do I avoid dirty what?
Dead reads in the database. Data come when two person updates the same record.
Gotcha.
How do you handle it?
That would be a different strategy. That'd be a strategy that you would want to implement. Service worker isn't going to solve that for you. It's not going to make it any more difficult either. It's still just enterprise pattern for you to solve, right? So again, now in this case here, again, and I thought this is maybe what you were referring to, is we are going to, on activation, we're going to remove any old caches, any bad data, and we're going to force it to reload that stuff back in. So that doesn't really solve your problem, but it would potentially prevent you from having cache data that's really old, and now you're updating it, and it's not even in sync with the database anymore, right?
But activation is pretty much one of the opportunities you have to solve that problem.
Yeah.
Service worker is not going to do it for you, but it's the opportunity for you to do it.
So here's the event listener. Again, we've got self points to the service worker instance. We go ahead and add an event listener for activate, and then we can go ahead and code up our activate code here. Fetch. So fetch is the primary event handler for service workers. This is the number one that it handles every single call. It's the primary event. So once we've got it installed and we've got it activated, this is where most of the work is done. Usually if we're going to use message, we're changing some sort of config thing, and we will now want it to respond a little different. And ideally something like fetch then would look at that config and go, oh, they changed that. Now we want to do it like this. So it's an opportunity to intercept network requests and cache data. So this is where you get the real power. You can now start intercepting and saying, hey, am I online? If I'm not online, then let's go get cache data. If I don't have cache data, let's display this HTML instead, saying that we're offline. Okay, cool. I can start to upgrade or degrade what's going on based on my whether or not I'm online or not. So again, here's our fetch. Really, really simple. The only real difference, and we'll cover this here, we're adding our event listener on fetch, and notice we say return fetch with the event.request. Anybody got an idea why we might do that? All right, so the reason we do this is because if we don't do it, this basically is going to kill this fetch, okay? And we're not going to have anything happen. So at the bottom of your fetch, you're going to want to return the original fetch with the event request so that it passes it on and it's going to go on out the pipe through the network. Otherwise, basically, your request is going to die in here because it's expecting, oh, well, you handled it. I don't need to do anything. So that's one of those little gotchas where you're like, man, this should be working, and I don't understand, man. It's not passing requests anymore once I get that service worker loaded. Go back and check that. That's probably your problem. All right, so preload and cache. We can preload data and essential files during the installation. So this looks like data, HTML, CSS, JavaScript, anything that you feel like you want to have cache that you might need in an offline mode. I don't recommend that you go cache your entire database. It might have some really serious consequences on your user's device. They probably won't be very happy with you. But if you're putting your critical data, critical pieces for them to be able to pull the app up, then that's going to give them a very positive experience. It's going to feel like even when they're disconnected, that they've got a real live app out of the App Store sort of feel, and it's responsive, it's immediate, there is no delay. And we'll take a look at how fast this is in just a little bit here. So that's during the install. During the fetch, we can return data from cache if we have it. And we can just go, hey, we already got this data, zip it right to you. Otherwise, if we're online, we can go fetch from the network. And if offline, we can fall back to a preloaded offline page that says, hey, sorry, you know what, you don't have a network connection right now, and we don't have any cache data for you. So reattempt your request when you're back online. Great. Much better experience than the little toaster server error. Well, that didn't really tell me much. I don't understand what's going on. All right, so here's a little bit more detailed install. So in this case here, we're adding the event listener for install, and we're then on the event, we're calling the wait until. And on that wait until, we're actually using the caches object. And on the caches object, now, by the way, before we use this on our well, this is the install. Are we checking? Or register, sorry. On the register, we would have needed to check to make sure that caches existed. If caches isn't there, this code's going to blow up, and it's going to cause some new problems, and we're going to get some unexpected results. In this case here, we're going to assume that we've checked for caches in the registration, and so we go ahead and have this available. We'd load, the service worker would be registered, and the install would have an opportunity to fire. So in that case, we're going to open up the caches called site files, and when that promise resolves, then we're going to go ahead and return the cache, and then we're going to preload the cache with core files for the site. So it's going to go ahead and add all these files that are located in assets in the offline, and it's going to go ahead and add those to the cache so that they're going to be available to us. So this is a manual way of doing caching. We're going to look at a little bit more sophisticated way of doing it that's actually easier, a lot easier, and we'll talk about how we're going to handle that. Let's see here. This is the fetch. Very similar. We're going to go ahead and add an event listener for fetch. We're going to do the event respond with. Again, we're going to do caches, and we're going to match on the event request. So event request, if you take a look at this and inspect it, this is an entire object. But the match function will take in that object and match the URL on it and make sure that the URL and the query string parameters match. And if we do have a match, when this resolves, if we have a result, then we're just going to return the result. We got it from cache, touchdown. Okay, don't have to go to the server. And then we're going to check, and we're going to cover this here and why. If not, navigator.online. Really bad practice, right? Doing if not, usually not the way we want to do it, but it can be a little confusing. But this is actually the way you have to do it, because it's the only way you can definitively know that you're truly offline, not in some sort of quasi state. If this doesn't pass, then we want to go out to the caches, and we're going to match on the offline HTML, and we're going to go ahead and just display that we're offline. If this doesn't, if Navigator Online, or the not Navigator Online doesn't evaluate to true, then we can go ahead and again receive the return fetch event request. So now what we're going to do is what? We're going to go ahead and make a call back up to the server. We're going to go ahead and have the app attempt to go get that data. So this goes back to the original point. This is offline first. This is the concept of thinking about, I'm going to make online be a luxury. If we got it, great. Otherwise, we're going to code to all the offline. Okay? So only in the event here where we don't have it in cache, and we're offline, we're just going to send a little page up saying we're offline. Otherwise, we're going to go out and we're going to attempt to go get data. We're going to take a look at a couple other examples of this that are kind of cool here in a minute. All right. Any questions so far? Yeah, go ahead.
Cache megabyte limits.
That's a good question. Don't know. We'll talk about where you can find out that answer, though, at the end here, okay? Any other questions real quick? Yep.
Yeah, I was just curious about when you actually make a request, it'll automatically, without you need to even specify in there, store the data corresponding to that URL, right?
Let's go back
Cache
to...
it. When
Um,
you first make a request, it does the return fetch, right? It'll goes and get that data from the server. The next time, we'll automatically have it cached.
John, come up here.
Yeah.
See if that doesn't help. See if that works.
Can you guys hear me? Okay, so my name is John. I'm senior developer here at Freebug. And the answer to that question, if you are not caching the information yourself, then it's not going to cache it for you. Service workers are pretty low level. They're not going to do a lot of stuff for you. They're giving you the opportunity to do things yourself. That's pretty much what it boils down to.
Got it. So in this example here, John, then what's going to happen is even though I'm fetching the data from the network, the next time I come through, it's not going to be in cache.
Correct, because at the moment I'm not actually doing anything to cache it.
Gotcha. And I think we're going to look at an example of that in a minute, right?
Yes.
All right, fantastic.
What we have done though is we did preload some pages and other content into cache. So anything that's there
Gotcha.
will be handled properly here.
Gotcha. Excellent. Okay, you don't have to turn it off. We just leave it.
Example,
Pardon me?
in your previous install example.
Yeah, in the previous install example, we added a bunch of pages and whatnot. That's really what this scenario here would cover is looking for any sort of pages that we pre-cached. I do believe we've got an example here in a minute that will actually show how we cache the data as well. So we can look at that example as well. Let's talk about cleaning up old caches real quick. Do we have another? Oh, John, you had a question.
So you mentioned fetch. Excuse me. Is that related to the fetch API, or is that separate? Okay.
It's fetch.
So like, I would have to use the fetch API to use service worker.
No. Well,
Yes.
yes, but no.
Okay.
All you have to do, if you wanted to do something outside of just passing this on to the network, and you wanted to modify this request, yes, you'd have to use the fetch API. Otherwise, in our case here, you're using the fetch API because you're just passing it. You're now passing this event request on to the fetch API for it to request it, and it's going to come right back through. So it's kind of a yes and a no. It depends on what you want to do. If you want to modify it and make it more robust and do a whole bunch of really cool stuff with it, hey, you're right. Fetch API is your way to go.
But in the app that's like outside of service worker, I would have to use fetch for that, for it to let go through the service worker.
No.
Okay.
No, it's actually, think about man in the middle.
It would intercept any HTTP requests.
He is going to intercept, the fetch is going to intercept all of your HTTP calls, whether you want it to or not. If you have a fetch hook method there, on your service worker. If you don't have that, then it's, it may have a default, I don't know, but it's going to basically bypass and just go straight back to the server. So you can do a lot more stuff with it, and like I said, we'll cover that in just a second here. Okay, clean up old caches. So during activation, it's an opportunity to remove unused cache data. So again, activation happens either when I fire it up for the first time, so at that point it got terminated because we probably closed down the browser, now we're reactivating the browser, or it got terminated in some other way and we're reactivating it, or we've installed it for the first time as well. So this is our chance to remove any old data that we don't want sticking around. Let's say it's been a couple of days, couple of weeks, couple of months. We don't want to display a bunch of old data if we've updated it. So here we've got an activate method here, and we've added our listener. We're doing our event wait until, and then with our caches, we're going to basically get all of our keys, and when those resolve, we're going to do a promise all on keys filter, and we're basically just going to be removing each one of these keys using the map and call caches delete on each key. So it's a really simple, common way of just, hey, I want to get all the cache stuff out of there and make sure we don't have any old data. Okay. Let's see here. Keep cache updated.
This gets into answering your questions from previously.
Gotcha. So during fetch, cache data retrieved from the network. So this is yep, okay. This is our little more broad example, and this will kind of cover some of this. So we have a bunch of site files that we're going to add to a const. And we have our function here, which is fetch and cache. So we could have had our previous example there on fetch call this method instead, passing it the request. And in our case here, we're going to return a fetch using that request. And then when it resolves, if we have a response, we're going to first see is a cache name in one of the site files in this array up here. Let's see. So if it's not, then it's data. Otherwise, it's site files. Okay. So in this case here, we're actually setting up two different caches, one for data, one for site files, so that we're not crossing them over in case we have any sort of naming conflicts or whatnot. So in this case here, we're going to return caches open. Okay, and so that's going to open up using either data or site files. And once that returns, then we're going to take the response, we're going to clone it with the request, and we're going to put that into the cache. So now this is not only have we fetched it, now we figured out which cache do we want to put it into, and then on top of it, we're going to take that request with a clone of the response, and that's going to be cached now. So now when we go back over here, and
continue because I actually haven't updated these.
oh, you have everything updated on the other side? Excellent. Here we go. So now it's the same exact example we had before on the fetch. We're matching on the request. If we have it, then it's from cache. We return the response. If we're offline, then we go ahead and send the offline. And otherwise, now we're returning instead of just fetch. Now we're saying fetch and cache, passing the event request to it, and now it's being cached. So hopefully that answers you guys' question on how to handle that. Great. All right. So now we have the Service Worker API family. So what we have here, and we'll make these slides available to you so you can get to them. I'll go ahead and post it either tonight or early tomorrow morning, the link for all the slides. Also in about 10 days, we'll have this video available to you as well. So in here, we've got different links to the Service Worker. I can get more information from the MDN on what are the properties, what can I do with it, get into some example code here. There's also for cache storage, cache, fetch, web worker, so on and so forth. So some really good links here for you to work with. Let's see here, the cache API. So this is designed to work hand in hand with service workers. Again, that's actually right here on the MDN. I can read up more about the API here and learn about cache match and how this works, or match all. I want to add cache or add all. You can see, you've got your entire spec here for all the different things that you can do. So it supports multiple stores of cache data. We've already seen that, where we had one cache for data, one cache for static files. And this is a living standard. And what we mean by that, it's constantly being grown, it's changing, it's evolving. So refer back to the documentation, keep up a little bit if you're writing this type of code. Get in the change logs, see what's going on, see what new things might be available to you, because it's not like the spec is done and no more. And it's promising. All right, Fetch API. So this is the modern replacement for XHR. It's simple, it's easy to use, it's living standard as well, and it's also promising. We saw this when we were fetching, and once we get the data back, now we can take and resolve that problem. Once that promise resolves, we can take that data and we can put it into the cache. We can do other things with it. So there's also the Web Workers API. So Web Workers is the parent. If you want to think about it that way, it's the parent of service workers, and it's the underlying background workers API, also living standard. So about this, again, you can go out and click on the links for this, dig into the documentation, see some other stuff that you might be able to do with this. All right, so then we get into service worker pre-cache. This is, I believe, the one item we're going to take a look at it tonight in a little bit of a deeper dive. We're going to do a little bit of live coding. Again, I warn you, this is see how this goes. But this generates a service worker for you. So instead of having to figure out what files you want to include or how you want things to work, what if we could actually just have a service worker or a library that actually help us build the cache for us so that we don't have to do it manually? Seems like a great idea. I'll show you how easy it is. It's actually very, very quick, and we can create an offline app. So it pre-caches site content files. So it's not going to do a bunch of other crazy stuff. It's not going to do a bunch of data, but it is going to make it so our app will run in an offline mode. Here's the command. So basically, in this case here, we're calling service worker pre-cache. We're telling it the root is the dist folder. We're saying the config file is the service worker pre-cache config JS, and we'll dig into what these do and a little bit more about that. We'll actually take a little bit closer look at this for the pre-cache config. And toolbox. Toolbox is where I want to stop for right now, and we're going to come back to this at the very end and talk about some additional optimizations. So at this point, we're going to go ahead and switch over to some live code. Does anyone have any questions before we do so? No, we're good? Awesome. All right here. So